Good morning. It is Tuesday, September 29th. I'm going to go over day 2 of section 211 for algebra. Please write down that your homework tonight is going to be to finish off the review and preview problems, which is numbers 9 and 10. So yesterday we were looking at patterns and how they grow and how we can extend them to get out to figure 100. Today we're going to look at what if we know the table, or if we're filling in the table based on the equation. So with the equation, we are told, right with the brighter color, that y is equal to 3x plus 1. So if that doesn't make sense right off the bat, x is representing the figure number, y is representing the number of tiles. So if our figure number is 0, 3 zeros plus 1 is going to give us 1. If we change it to 1 for our figure number, 3 ones is 3. 3 plus 1 is 4. Change it to a figure number of 2. 3 times 2 is 6. 6 plus 1 is 7. And you may have already noticed a pattern that's developing here. If we go to 3, we'll see if our pattern continues. If our figure number is 3, 3 threes is 9, plus 1 is 10. It appears as though it's always adding 3 because we're always getting one more group of 3. If we add 3, we get 13. Double check it. 3 times 4 is 12, plus 1 is 13. So just by looking at our equation, we can make some connections to our table. First of all, we're starting, our beginning number is 1. Okay? Because we're adding 1, regardless of what our figure number is, if our figure number is 0, we're always starting with the number 1. Then, because we're always multiplying our figure number by 3, multiplication is just repeated additions, we're adding groups of 3. So you will see that we're always adding 3. And that repeats for every figure number. So we know it's going up by 3 and it started at 1. To find that growth in the table, as x goes up by 1, what is the y value increasing by? That's pretty simple. What did we start at? We're always referring to a starting value when x is equal to 0. We see that same thing in the equation. If x is 0, our starting value is always going to be the constant that's being added on, and our growth is always going to be the coefficient of x, or that value that's being multiplied by x. So then it asked us to go back and look at our patterns in problems A, B, and for patterns A, B, and C, which we had in problem 1, 2, and 3. So we have somebody else who has a new tile pattern, but they're not going to show it to us. And we have to figure out how many tiles are in figure 100. What do we need to know? Well, basically, in every situation, we need to know what are we beginning with? What is in figure 0? Whether we know it from the equation with that value that's being added or subtracted, whether we know it from the picture, or whether we know it from the table, we need to know how many we're starting with. The second thing we need to know is what is it always growing by? Here we had 3 tiles being added every time. Here we had 2 tiles being added to each figure. In the equation, we knew that it was always growing by 3. We could tell that in a table by what is the y value increasing by when x goes up by 1. If we know our starting value and what it's growing by, then we can figure out what figure 100 would be by extending that pattern. And then in number 5, we just continued another example. We have a pattern. We know figure 1, we know figure 2 and figure 3. You have to figure out what's always being added to go from one figure to the next. Work it backward to get figure 0, work it forward to get figure 4. We want you to write an equation for that. We want you to make a table so that we can see that increase and the starting value. And we want you to compare that, what's similar and different in this pattern compared to the one in the table. What do those similarities and differences that we point out here, how are they the same in the equation? How are they different in the equation? And how do the similarities and differences look in a table? So what is it about the pattern that's the same and different? Basically, it's going to be, we're always adding in the same location, but that location from one pattern to the next is going to vary. When we're looking at what's the same in the equation, if we're always adding the same value, it's always going to be y equals mx plus b. But that starting value is going to be a different value for figure 0, or could be a different value for figure 0. And what it's growing by could change. Same thing happens in a table. What are we starting with versus what is it going up by? And I'm going to make my tables go vertically. So if x is our figure number, y is the number of tiles. I'm only going to do up to 2. We could start at 4 tiles in one pattern and always add 3. So it'd be 4, 7, 10. You're still always consistently adding the same number, and we're starting with our figure 0. In a different pattern, we could start at a different value, but whatever we're adding is always going to be consistent. Again, if you have questions, please log in at 2 o'clock someday this week, Monday through Friday, except for on Wednesdays. Have a good day.